Good morning Year 9 and welcome to today's maths lesson. Let's start off with a quick starter. Can you please list for me the first 5 multiples of 8? Find for me 1/7 of 28 and then find for me 4/7 of 28. Please pause the video and in your light blue books answer these questions now. Okay, let's go through the answers. So the first 5 multiples of 8 are just 8, 16, 24, 32 and 40. Owen, what's 1/7 of 28 for me? 4, great, so we've just done 28 divided by 7, which gave us 4. So if 1/7 is 4, Sophie, what's 4/7 going to be? 4 times 4, which gives me 16. Thanks, Sophie. Okay, let's have a look at today's lesson. This is where we're headed. We're going to be making factor trees that look similar to this. Looks way more complicated than it actually is, don't you worry. So as a starter, let's remind ourselves what a prime number is. Now we said a prime number was a positive integer which only has 2 factors. So like 2 can only be made up of 1 times 2, 3 can only be made up of 1 times 3, 5, 1 times 5, etc. The factors are always 1 and the number itself. Some non-examples are down here in the other corner. So using your notes from last lesson, can you please work out what's the first prime number, what's the only even prime number, and continue to do these 10 questions in your light blue books. Pause the video for 10 minutes or so using your notes and work these out now. Okay, let's look through the answers. You should have got 2, 2, 2, no, 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 29, 17, 13 and 31. Okay, in your dark blue books, can I have the title Constructing a Factor Tree for me today, please? And when you've got that, can I have pens down and eyes on the board? So my first one says construct a factor tree for 12. I'll go through an example and then you're going to do an example on the other side. So option 1, I take 12 and I think I need 2 numbers that when I multiply them together, I get 12. They can't be 1 and 12 in this case, otherwise we're not going to be able to carry on with our factor tree. But Ryan, what are the 2 numbers multiplied together to give me 12? I'm going to assume you said 2 and 6. But you could have also said, Ryan, 3 and 4, and that would also work. Okay, Dylan, over to you. I want 2 numbers that multiply together to give me 6. 2 and 3, great. And Josh, 2 numbers that multiply together to give me 4. 2 and 2. I can now write 12 as a product of prime factors. All that means is a load of prime numbers multiplied together that will give me 12. In this case, we've got 2, 2 and 3. If I do 2 times 2 times 3, I get 12. So I've written 12 as a product and multiplication of prime factors. Notice that no matter which option you took, you still end up with 2 times 2 times 3. So you can go any route to get there. I've put them in numerical order, so I've gone lowest to highest, as that's normally the way we'd do it. Can you now, in your dark blue books, pause the video and draw me a factor tree for 24 for me? Pause the video for a couple of minutes and have a go at that now. Okay, let's go through the answer. We've got 24. Now you could have done this in multiple ways. I'm going to start by splitting 24 into 3 and 8. I can't split 3 up anymore, so 3 stays as it is because it's a prime number. I can split 8 into 2 and 4. I can't split 2 up anymore because 2 is a prime number, but I can split 4 up into 2 and 2. I can then write 24 as just 2 times 2 times 2 times 3. And that's 24 as a product of prime factors. Your tree might look different, but your product of prime factors should always look the same. Okay, make sure you've got that example copied down in your dark blue book. And ABCD cards for me, or ABCD in your light blue book. What number should replace the question mark on the first step of this factor tree? Pause the video, have a little think. And cards up for me, or light blue books up for me. Okay, I'm looking for A, 8, because 3 times 8 would give me 24. Okay, can you now pause the video and in your light blue books, can you have a go at these 6 questions for me? Sorry, it's cut off a little bit of it, but that's question 1, that's question 2. There's a 5 there. Have a go at filling in the blanks for each of these questions, so where the blank boxes are in your light blue books, and then write each of these numbers as a product of prime factors. You've got 12, you've got 36, you've got 48, 50, 32 and 75. I've given you some helpful hints to help you out, so I've said you can write 36 as 3 times something. However, you don't need to use them if you don't have to. Pause the video for 10 to 15 minutes and complete these prime factor trees for me. Okay, and these are the answers you should have got, Year 9. Please check your work. 50 is 2 times 5 times 5. 32 would have been 2 times 2 times 2 times 2 times 2. 3 times 5 times 5 would give you 75. Please check how you did. Okay, back into our dark blue books. I'm going to do an example and then you're going to do an example. I've said, can I express 24 as a product of prime factors? And this time, I'm going to do it using index form. So in exactly the same way, I start by splitting my 24 into 3 and 8. I'm going to split 8 into 2 and 4. And I'm going to split 4 into 2 and 2. I've got 3, I've got 2, I've got 2, and I've got 2. So that's going to give me 2 times 2 times 2 times 3. But I can write 2 times 2 times 2 as just 2 to the power 3 times 3. So here I've written it in index form. Can you now, in your dark blue books, have a go at doing 48 for me? Pause the video for a couple of minutes, draw out the prime factor tree, write out the product of prime factors and see if you can put it in index form. Off you go. Okay, let's go through the answers. I was looking for 2 and 24. And then it's going to look just the same as the one I did. 3 and 8. 2 and 4. And 2 and 2. I'm then going to circle all my primes. There's 1, there's 2, there's 3, there's another one, and there's another one. So 48 can be written as 2 times 2 times 2 times 2 times 3. Dylan, how many 2's have I got? 4, lovely, so that's 2 to the power 4 multiplied by 3. I'm going to rub that out to make that a little bit clearer. So I've got 2 to the 4 multiplied by 3, and that's my prime factorisation, or my product of primes in index form. Okay, Year 9, ABCD cards or ABCD in your light blue books. Where's the first mistake occurred in this prime factor tree? Right, the answer I was looking for was A. The first mistake is that 7 times 8 is not 54. 7 times 8 would give me 56. The other mistake they've made is they've said I can split 2 into 2 and 1. You don't need to do that. We need to stop at the last prime number, which would be 2. Okay, ABCD cards. Write 40 as a product of prime factors. Okay, let's go through it. 4 times 10. 10 and 4 are not prime numbers, so that's not prime factors. 2 times 2 gives me 4, times 5 would give me 20, times 5 would give me 100, so it can't be that one. 2 times 2 gives me 4, times 2 gives me 8, 8 times 5 would give me 40, so we can have that one, C. And 1 is not a prime number, so it can't be D. Okay, in your light blue books for me, please, can you now have a go at these questions, Year 9? Question 1, 2, 3, 4, 5, 6, 7, and 8. Each time drawing your prime factor tree and then write it as a product of prime factors. If you can write it in index form afterwards, even better. Pause the video for 15 minutes and have a go at these questions now. Okay, these are the answers I was looking for. Please check your work. This one could be written as 2 squared times 5 if you'd done it in index form. This one could be 2 squared times 3 times 5 if you'd done it in index form. This one would be 2 squared times 3 squared in index form. This one would be 3 squared in index form. And this one would be 2 squared times 3 squared times 5 squared. Anyone that got the 900 right, an absolute superstar, well done. And finally, this was our lesson destination for today. Can you pause the video and spend 5 minutes having a go at this question for me? Can you write 225 as a product of its prime factors? And these are your answers. You should have got 3 times 5 times 5 times 3 or 3 squared times 5 squared. I'd prefer it if you wrote it in ascending order. So like 3 times 3 times 5 times 5 or 3 squared times 5 squared. But notice the mark scheme will accept it in another order and will still mark it correct. Fantastic, Year 9. Thank you very much for today's lesson. Can you now go into Google Classroom and complete the exit ticket I've set for you? Have a lovely day.